Hello everyone, I am Abhishek Bhattarai and this is my second task as an intern at the Spark Foundation. So here I have done a project on prediction using unsupervised machine learning. So here I am a part of a graduate rotational enriching program at the Spark Foundation. So here it first about know about what is unsupervised machine learning. So unsupervised machine learning is a type of algorithm that learns patterns from untagged data. The goal is that through mimicry, which is an important model of learning in people, the machine is forced to build a concise representation of its world and then generate imaginative content from it. So here if in this task we need to predict the optimum number of clusters and represent it visually. So first here we will import the necessary libraries like NumPy, HNMP, Pandas, SPD, Matplotlib, .pyplot, SPLT, and so on, Seaborn, and here in the second step we will upload some more datasets. So here we are doing our work on a rich dataset. So here generally we can import it through the library of Pandas, sklearn dataset, and the other way we have our provided dataset through the Spark Foundation. So here also we can upload dataset. So there are bit difference in the both dataset here, like in dataset uploaded from the Google Drive have a bit of change. Two columns like ID and species are just added. So here we will begin with the dataset that we have imported from the library. So here first, so here we will first check our dataset first look div to thread, then we'll check our div.tail, the last 5 rows. So as here we begin, we will count the number of rows. So first we will just explore the dataset, means information, what dataset, how many rows and columns are, info, describe, and duplicate values, and we will check here missing values, null values, and we will visualize the missing value also. And then as a part of machine learning, so EDA, we have to do EDA. So here we are doing EDA. Then let's, so here we are just planting a pair plot. So a pair plot is a pairwise relationship in the data set. It will create a grid of axis where the y-axis belong to row and the x-axis belong to column. So here we have done our idea with the use of various graphs and the various Python codes. Here we have created a causal heat map deviation code, and here so you can see that here we are just standardizing data using these codes. And here we have started our unsupervised machine learning in the core process. And here we are finding the optimum number of clusters, and we have used here the elbow method. So here you can see here we have used the code, and so basically elbow method is using clustering. So in cluster analysis, the elbow method is a heuristic used in determining the number of clusters in a dataset. So the method consists of plotting the explained variation as a function of the number of clusters and picking the elbow of the curve as a number of clusters used. So here we are using the elbow method, and here we are just plotting some graphs to check the k-means clustering. So here we are finding the optimum number of clusters for k-means classification. So here these codes are written, and here we can found that the two number of the clusters, the one where the graph bends and WCSS within cluster sum of square then decrease significantly after that point. Here optimum value of k is 3. So here we are fitting the k means with using the value of k, and here using the codes and we are plotting the graph. So in this way our k means clustering we have concluded. So basically, claim clustering is a method of vector quantization originally from signal processing that aims to partition an observation into clay clusters in which each observation belongs to the cluster with the nearest mean. cluster CentOS or cluster centroid, serving as a prototype of the cluster. So means the cake means clustering algorithm is generally used to find groups which have not been explicitly labeled in the data. So we are using in business. So this is my project, friends, and so thank you for watching this. And this is how I concluded my second task of unsupervised machine learning. So thank you, everybody. Thank you.